All right, welcome to these examples. We just got 3 slides that we got to get through, going over the graphs of tangent, cosecant, secant, so on and so forth. So looking at this, graphing y equals 3 tangent 2x. The period. Period is found in this case by doing pi over the coefficient of x. So pi over 2, which is just, pi over 2. Vertical stretch, or quote unquote amplitude, is going to be 3. It's found the exact same way, absolute value of the trig function. Absolute value of the coefficient of the trig function. There's no shifting in this case. So I'm going to go straight to my table. I have x and y. X is going from 0 to pi halves with a midpoint of pi fourths, a midpoint of that of pi eighths, and then again you do 3 times this, so 3 pi eighths. My y values for tangent go 0, 1, undefined, -1, 0. So then we need to change things. Period, nothing has, or we already accounted for the period, so we don't have to worry about that change. Vertical stretch, that's going to affect our y values by multiplying by 3. Same way, 0, 3, undefined times 3 is undefined, -3, 0. Nope, cross that off a little bit messily. So now I've got all the information I need to graph this. When I sketch this, I'm still doing 2 full periods. So I'm starting here, going to pi halves. I have pi fourths, 3 pi eighths, and pi eighths. And then negative pi halves, -3 pi eighths, negative pi fourths, and negative pi eighths. I'm going from -3 to +3. And again, starting all the way on the left side, I'm starting at the top. So this goes 0, 3, undefined, -3, 0, 3, undefined, -3, 0. So if I'm graphing this, the easiest one to see right away is the one that's going on the inside of this. So we've got, I'm going to just warn, I'm really bad at drawing tangent functions. Yeah, sort of like that. Maybe go through the point and make sure that it looks like it's curved. So sorry, my art skills are pretty sketchy on these ones. So here now, I promise I will criticize you as much as you are criticizing me. This one, I personally draw like the other side of this. So it's showing actually more than 2 full periods, but that is a-okay. It helps us make sure that you have an understanding of like how this is going to be repeating. If you didn't have this portion of the end or this portion on the end, that would be totally fine as well. That's still 2 full periods, but it's sort of nice to show that you know what's going on over here. Okay, yeah, again, really sorry for these maths or for these graphing skills. Tangent generally looks like that, sort of like a cubic. I'm just really bad at drawing them when there's points that go with them. I don't know why. All right, next, cosecant. So the period of cosecant is found by doing 2 pi over the absolute value, the absolute value of the coefficient. So 2 pi over 2, which is just pi. The vertical stretch or amplitude here is 3. Again, it's not exactly an amplitude. We didn't talk about it here. The reason that it's not exactly an amplitude is by definition, amplitude is half the distance between the minimum and maximum. Well, the problem here is that there is no minimum and maximum. This continues infinitely in both directions, up and down. And that's why tangent, cotangent, cosecant, and secant don't have what's technically an amplitude, but it works the same way. This is a reflection over the x-axis, which is a change in our y values. So again, you have 2 ways of doing this. You can first sketch the sine graph, or you can go straight to the cosecant graph. And it really is a matter of whether or not you're more of a visual person or a, just algebraic person, I guess. So it's up to you. I personally like to just go straight to the cosecant points. But in order for me to do that, I always sort of list out like sine. And I'm like, oh, sine goes 0, 1, 0, negative 1, 0. So cosecant goes undefined, 1, undefined, negative 1, undefined. Now, if I go and make this table, I have my x's and y's. I have no horizontal shift, so I can make a small table. 0 to pi, pi halves, pi fourths, 3 pi fourths. My y's for cosecant are undefined, 1, undefined, negative 1, undefined. So I've dealt with the period, the vertical stretch I have to apply. And I can also apply the reflection over x because this is really just multiplication by negative 3. So this is undefined, negative 3, undefined, 3, undefined. Now if I go to graph this, I'm going from 0 to pi with pi halves, 3 pi fourths, negative pi, negative 3 pi fourths, negative pi halves, and negative pi fourths, going from negative 3 to positive 3. Again, starting all the way to the left and all the way at the top, this is undefined, negative 3, undefined, positive 3, undefined, negative 3, undefined, positive 3, undefined. And what you may want to think about, although it's not particularly necessary, you have, a sine function going in between these. So you have something going like this. And this is where, like, if you wanted, you could have drawn this red line first. You would have had to have gotten all the points for sine, but you could have drawn the sine function first, and notice it's still going through those points. Anywhere where sine was 0, the function is undefined. But then your actual answer to the cosecant is simply these u and n shapes, sort of like mini parabolas everywhere. So these in blue are all your cosecant functions. In red, that's the sine function that's going between those, which is not necessary for you to draw, because it's not technically an answer to the question of the graph of cosecant, but it is a helpful guide sometimes. One question that I sometimes get is when people are like, how do I know if I just had these points and didn't have this red line, which way these parabolas are supposed to go? Because some go up and some go down. Well, the ones that are like lower are always the ones that go down. The ones that are higher are always the ones that go up. Because you have to remember that there's supposed to be a space in between that the function would never actually get. Like I can't get 0 in this case, since the blue is never going to be at 0. All right, one more example, just cotangent. Y equals 2 cotangent x over 3 minus 1. If I am looking at this, the period is going to be pi over 1/3, which gives me 3 pi. Vertical stretch or amplitude of 2. And this is shifting down 1. I know that it's down because it's not in the parentheses. So once again, I can make a small table because there's no horizontal shift. Horizontal shifting does occur with these, just not in our examples. We're going from 0 to 3 pi. The middle of that is 3 pi halves. Don't give me 1.5 pi. The middle of that is 3 pi fourths. And 3 times that is 9 pi fourths. My y values for cotangent. So tangent we said goes 0, 1, undefined, negative 1, 0. That's tangent. Which means cotangent will go undefined, 1, 0, negative 1, undefined. So undefined, 1, 0, negative 1, undefined. I have both an amplitude and a shift down. The amplitude has to be applied first because it's multiplication. then I will shift things down. So 2 times undefined is undefined, 2, 0, negative 2, undefined. And subtract 1. Undefined minus 1 is undefined. 1, negative 3, undefined. So now I'm going to go graph. I've done all of the transformations. And because this is a tangent or cotangent function, my graph will probably be not very wonderful. I always apologize. 3 pi, 3 pi halves, 3 pi fourths, 9 pi fourths, negative 3 pi, negative 9 pi fourths, negative 3 pi halves, negative 3 pi fourths. Going from 1 to negative 1 to negative 3. And starting all the way to the left at the top of this list, I go undefined, 1, negative 1, negative 3, undefined. And notice that undefined is supposed to be happening at 0, and it is. 1, negative 1, negative 3, undefined. Draw my cotangent function going between these. It was a little bit better. I'm, again, just notoriously bad at drawing these. Ooh, that one's sort of nice. Yeah, so cotangent has that sort of shape. If you look at cotangent versus, I'm going to go back 2 slides. Tangent, you'll notice that it's just really a reflection. But it also, there's points that change and everything. This is 2 full periods of our cotangent graph. This was 2 full periods of cosecant. This is not 4 periods of cosecant. That's also sometimes confusing. You have to have like this downward parabola, upward parabola. That is a period. And now here that is repeating itself. Downward parabola, upward parabola. Remember, period has to be repeating that entire thing. All right, that's it for section 4.6. It's essentially just 4.5 with some different y values. But the whole idea, the whole process is exactly the same. It's just new y values that you have to sort of think through. Get started on some of that bookwork. See if you have questions. Make sure that you ask them.